maybe we'll give folks a chance to sit down and settle in. And please come forward from the door. There's like a lot of pressure there. You can sit on the stairs if there's a fire concern. I assure you it's worse to stand right next to the door.
Thank you.
Thanks. Awesome. Hello, everybody. I'm Daniel. I'm the CEO, one of the co-founders of a company called Modulus. And, you know, that's a very sexy title and all. But I thought maybe I would start today by telling kind of a personal story, something that will require me to be a little bit vulnerable, and I might shed a tear or two. So a couple weeks ago, this is a true story, by the way. I'm going to change the names just to be sensitive to privacy, but it is a true story. A couple weeks ago, I was going to my general practitioner or general care physician, right, to get my annual checkup. She's lovely. Her name is, well, I know her as Dr., let's call her Dr. Chung, Lucille Chung, right? And I always call her Dr. Chung as a sign of respect, and also because I've developed a small crush on her over the past couple years. And I've been trying to be good about my fitness. And every time I reach out to her or talk to her, she always says, "Oh, don't call me Dr. Chung, just call me Lucille," right? And I thought, okay, that's like some bantering. That's very cute. But this time, after all the exams and so forth, she's like, "Please, Daniel, just call me Lucille. I'm not a doctor." And that was devastating for me. Because, and I checked afterwards, I looked for her certificate. She's not a doctor. She's a nurse practitioner, a very good one. Could have fooled me. But she really wasn't trying to fool me. She was trying to tell me that she's not a doctor. She's a nurse. And that was devastating. My crush went away. I guess it was bound up in kind of the power dynamics and all that. My parents always wanted me to be a medical doctor, and I never did that for them. And I thought maybe I could bring back somebody who was. But the bright side is it helped me understand, in a very visceral way, I think the trend that will basically define our era, right? So here's a graph of the number of doctors over time. You can see that's let's say where we start. And it's going to grow because, and this is for sure the case today, the demand for medical professionals far outstrips our ability to provide or supply medical professionals, right? But then something interesting is going to happen, right? I think we're going to start to see a decrease in the number of doctors in our society. And that reduction will accelerate until we hit some basic carrying capacity, right? A holding pattern, if you will. And these will be really specialized doctor or really advanced, really talented folks. But for the most part, we're going to see that reduction. I think that's not just going to be our doctors. It's also going to be our lawyers, our teachers, our consultants, our politicians, our bankers, and so forth, right? And if you read the first title, you know what I'm talking about, right? I think that this will be caused by AGI, right? And then just roughly to define our terms, AGI for me anyways, is just any algorithm which is just as good or better than a human being would be at that specific task or general tasks. And maybe just as importantly, they will be cheaper, right? So we're going to see these models scale. We're going to see this massive transformation in our society, slowly at first and all at once, because life will be better the day after for the vast majority of us. But there's a problem with this, right? Or kind of interesting situation that's going to happen in this transition, which is that we might see something like this, right? When we go visit our GPT interface one day to check up on our health, right? And you're faced with a choice, of course. GPT-5 doctor here saying that, look, we think that you have cancer. We looked over your charts. We want to recommend some treatment, some therapies. You should get started. And just to kind of gauge the crowd's kind of general acceptance of this new world order, who here would start chemo or whatever treatment was recommended the moment they see? Okay, we got one. Okay, a few more. Great. And it's kind of worth, at least for me, thinking, because I too would be a little bit uncomfortable, right? I studied AI.
It very much depends.
It absolutely, yeah, 100%, right? But I guess part of what I'm trying to unpack is what does it depend on, right? Like what's exactly the difference between not Dr. Chung telling me that, oh, your charts look good versus an AI model, right? Certainly the stakes of the recommendation matter for sure, but maybe deeper within that decision making, here are the couple things that I could think of, right? Okay, is this GPT-5 doctor actually a certified medical professional, right? Does it meet some standard that I would expect from somebody who could make that kind of recommendation, right? are the reasoning, right, the literal like rationale that motivated that recommendation grounded in sound scientific medical reasoning, right? What's the history of GPT-5 doctor, right? Have they diagnosed anyone else before correctly, hopefully? Like what's the scoreboard looking like for GPT-5 doctor? And finally, and this is maybe a little bit trivial until you start to think through kind of the implications of what happens when this goes wrong, am I even getting the right model that's recommending this thing, right? Is it some fraudulent model or something that's like not quite up to par, right? I think a lot of us here experienced when the performance of GPT-4 went down or decreased about 2 months after release. We definitely don't want that from our GPT-5 doctor. So to kind of try to pull all of that together, I guess what I'm trying to say is that AI is both unknowable and unaccountable. And this is not new. For anyone who has been in the AI literature, these are really pernicious problems that are very, very hard to solve. Right? We have these incredible algorithms that have these like really high semantic output environments. And it's just very difficult to put this thing in a box and label it and understand it. So how do we solve this problem? Right? Because again, the AGI revolution is coming, and the world will be a better place. So how do we make sure that we're all okay in that world, right? Well, certainly, in the context of this GPT-5 doctor, it would be awfully nice to have a medical degree qualification. It'd be nice to get that scientific sound thought process, right? Make sure it's explainable. We certainly want to know that the model isn't inebriated or affected in any way, just as we wouldn't want that for our doctor. And finally, we definitely want to know that we actually got that specific model to give us a diagnosis. So these are really nice things. And kind of the thing to note here is these are things that we generally have for human beings, right? I guess Lucille, not Dr. Chung, we can look her up and find all these things about her record. But for a model, this doesn't really exist, right? The closest thing maybe is like a model card on Hugging Face or something. But even that is relatively primitive compared to I think what we really need to see in order to see this scale. The other thing is these 4 attributes are really in quite a bit of tension with the things that we know for sure about AI models, right? That they generally involve really sensitive, valuable IP, and that they're super expensive to run, to test, to deploy. Right? If you pick any of the attributes on the right and you hold it in tension or in contrast to the things you see on the left, it's a bad time, right? And as mentioned at the top, right? If this world is going to happen, we need to resolve this tension. We need to have something here that makes sure that they can all kind of fit together, right? And the answer is super obvious. Y'all are probably already thinking about it. It's just centralization. Let's get the government to come in and regulate these things, or let's get a company to come in and certify these models and then pass it through a specific gate, and the world will be great, right? That's the model. That's us. Let's put something in between. It's red because it's good for us, right? It's not evil. All right, cool. So that's the world according to Daniel. That's the world that kind of we're speeding towards. It's already starting to happen, and it's only going to pick up pace. But in a parallel world that's not so far away, some other things are also happening, right? And this probably won't be too unfamiliar to many of you in the crowd. All right. They are zero-knowledge proofs and zero-knowledge machine learning, which is an application of the former to specifically AI models. So really quickly, zero-knowledge proofs, ZKPs, historically has been considered this privacy and compute integrity technology, right? So it's been great for scaling blockchains. We won't get into exactly how it works. You can look that up. But then the application of that technique to machine learning gives you something called ZKML, right? And in particular, I want to highlight this feature of ZKML we call polynomial commitments for model weights, right? Basically, this is the promise that we can make on behalf of a model that it is a specific model which is servicing you, right? In other words, I am putting a specific AI model to the test. You, the consumer, can go for it, can test it, can do whatever you want, but I cannot secretly switch that out for a different model, right? That's the power of the polynomial commitment. So here is, revisiting that example that we started with. We have that model that's giving us a result. The first thing we can do once we have this polynomial commitment to ZKML is we can name the model. And we say, actually, this is GPT-5 medical, right? Version 1, version 2, whatever it is. Right? Here's how it did on the MCAT 522. It's pretty good. 260 on step 2, did well in residency. This is the history, right? It's performance over time. So it's correctly diagnosed a lot of similar situations. That hopefully gives you some more confidence. And finally, it would be great if we can also figure out the source of that specific result, right? And the cool thing about using ZKML to tie all these characteristics to the specific output that you get is that we don't need that red thing from earlier, that centralized third party. All of these rails, right, all these tests can be rendered using mathematics, right? And this is the idea that kind of we're really excited about. We call it commitments with Qualia. And just to define it really quickly, it's basically just statement of characteristics that we layer on top of that commitment to a specific model weight, right? And these are some of the cool attributes of this, this mental model, right? It's mathematically verifiable. It can be permissionless. It can even be privacy and IP friendly using the hiding properties of zero knowledge proofs. So here are some super cool examples of how this thing would work, right? Or what would happen on the other side. Right, this model demonstrates this performance on the validation set, so you know it's a really performant model. This model is robust against certain types of adversarial attacks. That's really big in the AI literature. It's a huge problem of getting models into production. This is cool. This is a negative example that the model generates a watermarked image when it's fed latent seeds of a specific configuration. In other words, I figured out that this model actually is trained on copyrighted data, and I want to point that out and prove it to the model kind of provider. So, to put it very succinctly, ZKML endows AI with qualia, right? That's the kind of quality and the characteristics of that model, as well as provenance, right? So where did that model come from? It is that specific model. And of course, in aggregate, this makes AI both knowable and accountable, and this is really key, without those trusted intermediaries, right? So we're going to kick out that guy, replace it with math. And really what we want is we want all that to disappear, right? We just want you to get AI results that are tamper-resistant, that are verifiable, that are correct, that have these qualia kind of layered on top of them. And we want all of the infra to be just removed. So this is the choice that we're facing, right? Centralized trusted authorities to govern the kind of safety, the security, the robustness of our AI models in high-stake environments, or math. Are we there yet? I'm going to say something very controversial. We are not there yet. But we're getting closer, which is pretty cool. So this is the ZK overhead performance. In other words, for every dollar of AI compute that we do, how many dollars do we need to spend to prove that that dollar of AI compute happened correctly, quote unquote, right? I.e. the rails of this commitments with Qualia, the foundations. So with a generic ZK prover that's primarily used in the kind of blockchain environments to prove VM operations, we're operating in the order of about 300,000x, right? So what is that good for in the context of ZKML? Well, we can build some prototypes. We can build a toy AI trading bot. We can build a toy AI game, toy AI art, all verifiable. And these are all things that we have done at Modulus in the past year. About 2 weeks ago, we introduced Remainder, which is our specialized ZK prover. It's specifically built for the instruction set associated with AI models, which is why it is significantly more efficient. Right? We're currently in production seeing about 200x overhead. And at that regime, we are now able to build out these new tools like WorldCoin's Iris upgrade, Upshot's NFT appraisals, so fair, consistent AI prices, and Ion's on-chain AI risk engine, right? So actually trying to figure out what is the probability of slashing of validator nodes, right? And we can talk all about this afterwards as well. The goal, right, what we call the Holy Grail, what we think is the Holy Grail, is to get to less than 10x. Right? We think this is the magic number where we can actually see commitments with Qualia scale. Right? And just really quickly, why? Well, if you take the smallest LLM that I'm aware of that's really performant, which is the Llama 7 billion, right now on CPU alone, it does about 100 milliseconds per token in terms of the forward inference pass. At the 10x overhead, that means about a second per provable token output from a performant LLM, right? And this is, again, just on CPU. We're not even talking about hardware acceleration yet. Right? We think at this threshold is where we actually see commitments with Qualia at scale, and we get to kind of take the alternate path from the centralized trusted authorities. That's a QR code to our Twitter, but you can just look us up. And yeah, I went very fast, but hopefully we can save some time for questions. Yeah. Oh, please, yeah.
So even a factor of 10 is considerable overhead, right? Like, well, what kind of scheme do you imagine that people are, like, how do you imagine that requests for commitment will actually, like, go into, like, the workflow, like, application workflow?
Yeah, that's a really good question. So I guess my expectation is that, in some sense, like we can always say, like, all right, in 100 years, my expectation is all AI proving, or all AI queries will be ZK proven, right? Just to be safe. It will become an expectation in the context of a production environment, right? We didn't talk at all about regulations. This came up in the panel just now. This would make regulations much more robust and much easier, right? So maybe that's a requirement. But you're absolutely correct. 10x is still a massive overhead. I think from my standpoint, definitely we are primarily focused on high-stake environments where, like, if we get the wrong result, the cost or the havoc that would wreak, is substantial enough to justify the overhead, right? So you can see in the early use cases, we're entirely focused on dApps, because in the crypto environments, compute's already really expensive, so there's some cultural acceptance. But yeah, we're definitely going to have to see that come down a lot for this technology to scale. Really good question, though. Yes.
Can you just talk a little bit more about your prover and the progress and what you guys recently launched?
Sure, yeah.
What was the question?
Yeah, so Casey asked, for us to talk, or for me to talk a little bit about remainder, like why is it, like this is a really non-obvious thing, right? Why we went from 300,000x to 180x. So to answer the question, this is probably not very surprising. So an AI model is like significantly simpler than a virtual machine, right? Just in terms of the instruction set, like we do not need to handle memory or registries or anything like that. We can just focus on basically matrix multiplication as well as some nonlinearities, and the map-mul operation itself is super parallel happy, right? And so when we first started the company, the insight was, look, if we build a ZK prover that's specific to just that operation, maybe we can make it significantly more efficient, or even if only slightly more efficient, over the scale of an AI model, right? If you're a few percentages faster on map-mul, you should be significantly faster, right? So that was the original insight when we started the company, and it seems to be proven true so far, right? At least on the AI compute dimension, I think Remainder should be the world's fastest ZK prover. I'm not sure that that's true, but I think it probably is. And it's not because we're like a bunch of grizzled old cryptographers. We have some of those, but it's just because, quite frankly, the problem statement's a lot easier. We've down-selected to a more specific type of issue. So that's a TLDR. Yeah, and we expect, by the way, we're doing already better than that, but we'll put out more papers soon. Yes?
Are you using any hardware techniques, or it's just, you can compress the tree, which you obviously stated, right, which gives you a lot of performance. Like, if you were to compare with growth, if you could throw away all the shit, you improve a whole lot. Now, if you have hardware, then it's a different game. Then this notion of 300,000 versus 180x is kind of hidden. What are you doing in the hardware? So curious. Yeah,
great question. Around kind of the hardware, like whether there's like specialized hardware or exotic silica that could be either already factored in or would be factored in. So this is all on CPU so far. So 0% hardware acceleration. This is how much low-hanging fruit there is in terms of parallelism and just like how fast we can go with more sophisticated, more elegant algorithms. On top of this, if we layer on exotic silica, we think we're already in the 10x regime, right? But we can't always assume that, right? It's unclear exactly where the AI compute model will scale fastest. So in these like 3 examples specifically, the lower 2 are kind of in the cloud model, while for the WorldCoin use case, that ZK prover is running on the edge on like an Android phone, right? So we only have CPU there. But certainly, yeah, we think that the case for faster ZK is like very optimistic. So yeah, I expect a lot more to come from here. But great question. Yes, please. Oh yeah, go for it.
About explainability, there is some research we're doing in that regard, because I don't believe there's knowledge we have.
Yeah, great question. Yeah, so there's a ton of incredible research that's being done around explainability. Part of that is it's just a very hard problem to solve. I would say the whole commitments with Qualia kind of framework is basically meant to be a really robust foundation for that explainability research to just like plug directly onto, right? Because basically, once we have this commitment layer kind of figured out, any kind of explainability action we take or analysis we make on a specific model or on a specific query can be trustlessly, again, with mathematics, tied to that specific output. Right? So in other words, we don't have to count on the government's word on that explainable result. We can actually publicly verify that that's true. So it's like, it's like human beings are these incredible machines that, where we kind of walk around, we make decisions, we express our opinions. But at the end of the day, one human is one human is one human, right? And that's pretty cool. Compute models in general don't suffer that kind of luxury, right? It just floats out in the ether. And ZK is an opportunity to put compute in a specific box. And we're saying, look, label that box, right? And with every label, we know for sure that it came from that compute, including any explainability kind of results, right? But it's a great question. Yes?
How modular is this? Like, for example, could I generate a proof that a model generated a certain output invariant of like what linear algebra library it used or something like that? And would that save costs over?
It's a great question, and it's around kind of how modular the framework is and whether we can have like different prover parties that make different attestations. And I think the general answer is it's probably very modular and can be very flexible. And this is more of a philosophy that Modulus, we specifically take around this. We just want to take really concrete steps that follow use cases, right? Or just lead the use case a little bit, because we want to always show that there is utility, right? Even when we were in the 300,000x regime, we were building toys and prototypes to show that there's like pretty fun stuff you can already do, right? But certainly, over time, I expect this to be much more flexible. And right, like this is a small teaser on that. But one of the slides earlier. There are a lot of slides, sorry. Oh, here we go. Right, this third example, like generating a watermark image, this is super interesting, right? You can build kind of a rewards program to get people to prove that your model isn't trained on copyrighted material, right? Or like a bounty program, right? Or any kind of model marketplace can go right on top of this. We haven't seen any of that work at scale yet, and we think a big part of that is because you need kind of a neutral substrate, right, to make sure that everything, all these competition, rewards, marketplaces are operating on equal footing, right? But yeah, it opens the door to all of that. It can be very modular for sure. Oh, okay, great, awesome. Thanks for y'all's time. Appreciate it.